Welcome back to the pipeline. Very special episode today. I'm drinking lemonade with James Hunsaker, co-founder of Monad, godfather of the parallel EVM, and CTO at Monad. James, how are you doing today?
I'm doing good. Well, how are you?
I'm fantastic. Cheers, and
Cheers.
special shout out to Barry and Oh My Like in the Monad community who put together these awesome drinks to keep us hydrated here,
Cheers.
albeit with some sugar as well. Cheers. Cheers. But we'll get right into it. I think one of the most interesting sentiments that I've heard from the community, especially recently as we've grown so much and added new members, people can't believe that Monad is even real. We are talking about 10,000 transactions per second, full 100% EVM compatibility, sub-cent gas fees, and hardware requirements that are very, very similar to Ethereum itself. How is the Monad team able to pull off some of these engineering feats that have been written off as impossible by many crypto participants previously?
Yeah, it's like modern hardware is pretty impressive stuff. Even in the last few years, like SSD drives that have come out are very impressive. PCIe 4, PCIe 5 is out. The bandwidth from these things are really impressive. The storage is impressive. The latency is impressive. And you just really need to build the software to take advantage of that. If you kind of just rely on, out of the box database software or out of the box, file system, this sort of stuff, there's just a lot of algorithmic overhead and complexity in that in terms of, and then it's just not optimal, and it's these types of software are optimized for sort of general use cases, and if you want anything like done to take advantage of performance, you really have to like specialize. And so you can't really use, coming from like some I mentioned before is like HFT, like you can't use general libraries, general sort of software or even hardware in some cases, if you want to kind of win like this latency race, which is the primary thing of HFT. So from our experience, you have to build everything from scratch, everything very low level. You don't rely on the operating system to do anything for you. You get that thing out of the way, get off to the side, and just focus and try to really understand the hardware, how the hardware behaves. I could go on for a long time about this, but yeah, there's a lot of efforts. Different SSD drives behave in different ways, which is annoying. We gotta benchmark on all these different SSD drives, figure out like why one is slower than the others for certain sorts of behavior. Some cases it's just slow, and that's just the way it is. But other cases maybe you need to tune or do something like this. So it's just a huge undertaking. A lot of this stuff takes a lot of time. You can spend days figuring out why something is slow on a certain drive or something like that. Days of engineers' time, maybe even weeks in some cases, to dive into certain sort of performance issues. And it just takes a lot of time. It's a lot of work. Can be frustrating at times. Can also be really rewarding. Like when you make a change and get an extra 10% TPS, like rah rah rah, everybody's happy. So it's just a lot of work.
So the hardware is there, but you have to fundamentally understand how hardware works. And not only that, but the various components of the EVM stack and how these can be optimized to squeeze the max juice out of that hardware.
Yeah, there's a lot of, made a good point, like there's a lot of understanding of EVM itself. How do people use EVM? Like, ERC20 contracts, Uniswap, all these sorts of things have certain usage patterns, and you have to dive in and like understand like how is the blockchain being used exactly, like what is the the pattern of the transactions, how they access state, how they are scheduled, as what is the relationship between one transaction and another transaction across blocks. We did like autocorrelation, like there's this thing of like autocorrelation, right? So like if you haven't used, an account is more likely to be used soon if it's been used recently, for example. That's just like basic sort of thing, but you know, to what extent is that true? Like you have to do statistical sort of analysis to really dive into that. What is the window? Like by, you know, it's not necessarily going to be used on the next block, but you know, if an account hasn't been used for a month, what's the likelihood it's going to be used, sort of thing. So you kind of arrange your data structures to kind of take advantage of this information. You know, if you kind of treat everything as uniformly accessed, you get a very different sort of behavior. And whereas, you know, the curve is probably more like this, like, you know, majority of accesses are a small number of accounts relative to the overall number of accounts. So you get, you know, you just, all this sort of stuff is analytics, trying to build data structures and software that takes advantage of that analytics, and it's just a continuous cycle of improvement.
Continuous cycle of improvement. I like that. There's clearly a lot going on behind the scenes here. I think most of the community knows we're in this devnet phase now. We have 10,000 transactions per second up and running internally. And the next step that everyone's really excited for on a macro level is to get to testnet. What's the difference between devnet and testnet, and what goes on behind the scenes between those two releases?
Yeah, so devnet is something we deploy internally. So like we're tolerant of maybe the software being a little rough around the edges. Maybe the box needs to be configured in a special way, and we kind of do that manually. Whereas if we were to make this testnet and get the software out, we can't expect people to do all these little details in terms of like configuring the box, setting up the software, configuring things. So a lot of it is just moving from devnet to testnet. A lot of it is just polishing the software, making it like a product that other people can download, run themselves, use, supportable. You know, you don't need a developer sitting there to debug an issue, sort of thing. So that's where a lot of our time right now is going, is just kind of making the process smoother. And even internally, we kind of have that going where, you know, developers kind of hand off to another team which deploys, and there's some communication. That's communication that can't happen if like you're having in testnet. So you just keep refining that and keep. And in the meantime, of course, a large portion of the team is always working on performance, optimization, speeding up. That's always going to be happening. Like, never going to end. Next so many years, always going to be making Monad faster. There's still a lot of juice we can squeeze out of this thing. So, but yeah, you know, it's kind of those two things in parallel going on right now.
10K TPS will be old news at some point.
Yeah, old news at some point. Yeah, we'll keep going.
Very exciting. And, you know, the entire time that Monad has been publicly worked on, L2s have been a very big narrative in crypto. And, you know, our team often gets the question, well, why do we need another layer one? Why not just launch as, you know, one of 100 plus L2s that we're seeing now? What's that answer from your perspective?
Yeah, so, you know, I think one is bandwidth. The bandwidth isn't there for the data availability. We're gonna, you know, first version of Monad is gonna be targeting like 100 megabit connection. That's let's say 8 usable megabytes per second of data. If you look at the existing sort of like data availability, it's not even anywhere close to that. So we would be constrained, and we don't want to be constrained, obviously. We want to be able to use the hardware as much as possible. The other part is just complexity. There's a lot of things you have to figure out to make like a decentralized L2. There's many different designs for that people are researching and looking into. Every design has a certain number of trade-offs that some maybe affect UX, some maybe affect some other aspect. So by building Monad and building all the components of Monad ourselves, And Monad is somewhat modular internally. The different pieces are somewhat built separate from each other. There's some communication between them, but generally separate, so it's kind of modular internally. But we can just avoid a lot of that complexity that would be needed to build like a full-on decentralized L2. And you never can tell where things are going to go with research of data availability and all that sort of stuff. Maybe Monad has that, maybe we use some other chain. It's hard to say, but our assessment is made like, here and now, like what can we do here and now, and it's just not really feasible. Doesn't really make sense to do it right now. So we just focus. We build the components, and we have full control of the system, and that way we can ensure we get the full performance that we need.
Gotcha. So the short of it is decentralization and performance. It's easier to make that happen if you launch as an L1.
Yeah, and UX.
Yeah.
User experience is easier. Complexity is simpler. There's a lot of, like I said, there's a lot of complexity we don't have to deal with if you go to some sort of like decentralized, or you have one chain that's doing data, one chain is doing execution, this sort of thing. There's complexity there. So we just avoid all that by just building everything.
Yeah, I find myself wondering, how in the world did you come up with the idea for this in the first place? You're obviously not swayed by the current narrative on crypto Twitter, but how did you get this idea and decide, like, yeah, let's go full force on this because it can actually make a really meaningful impact?
Yeah, I think with any idea, do you have like a competitive advantage? If it's just marketing, which a lot of people seem to have, if it's just pure marketing, then you don't really have a competitive advantage. So competitive advantage is like you can actually build something that maybe other people can't build. And our experience, being from HFT at Jump and other things, is just we have that experience building those really low latency systems. And we looked at the existing software that's out there, all the different L1s. L2s weren't really around that back then, but all the existing L1s, and look at their consensus mechanism, look at their execution, their VMs. Some had different VMs than Ethereum, like Solana. Looked into all these sorts of aspects and just felt like, different people had made different trade-offs that maybe we didn't agree with. Different people just copied software from different components into their own. And I think ultimately, like building it from the ground up, building it from scratch, you have a lot of control. And if you have expertise in that, then you can build something that's faster than what other people can build. So that's why we started it.
Yeah, it's clear that this is a problem that only a team with very deep and specialized experience could tackle. And even with that, it's clear that, these are challenging problems to solve. What's the biggest or one of the biggest challenges that you've encountered since founding Monad, either technical or non-technical?
Yeah, so technical is the database. I think I've mentioned before, like HFT doesn't use a database. The strategies will start up. In the case of your trading futures, it's like 23 hours a day. Strategies will start up. For 23 hours, they don't touch the disk. Like they just run in memory. Obviously, given the state size of Ethereum and other chains, your tens of gigabytes, hundreds of gigabytes of data, you have to put that on disk. And so technical wise, that's just kind of understanding new technology that we weren't personally familiar with, was a big lift, and that takes time. Like you got to learn it. I never worked for Samsung. I never built SSDs, so I don't really know. Never really paid attention that much to how they worked, or what their internal architecture is, or what the state of the art is with that stuff. So we had to learn all that, and that was a lot of experimentation, a lot of benchmarking, open source databases, see where they kind of fall apart. RocksDB, LevelDB, these different databases, LMDB, these different databases that other chains use. So from a technical perspective, that's probably the biggest lift for Monad. Just pure sort of like VM, transaction, execution, that's closer to what we used to do in HFT. So that was an easier thing to pick up and kind of leverage our knowledge there. In terms of company, it's always hard to find and hire good people. The employment market's very competitive. You got a lot of big tech, Google and Apple and these sorts of things. You have finance market, which, in New York, there's a lot of trading, HFT, investment banks, this sort of stuff. So, it's like you're competing in that market, and that's kind of a new thing for us. Yeah.
Yeah, definitely. It's clearly challenging on many fronts, but there's been a lot of wins along the way as well. And, we have a massive global community now that's really excited about a lot of this stuff, particularly getting their hands on, the testnet upcoming and, being able to actually try out some of these applications.
Yeah.
What are you most excited for?
The community is really cool. Always impressed. The art is amazing. I occasionally ask people, like, how do they make that art, right? Like, is this like, because nowadays there's like AI.
Yeah.
And, you'll see like, one of our community members sent me a thing where it was like the partial drawing, right? So I could see like the intermediate state, which was pretty cool.
Yeah.
But yeah, the community's really, really awesome. I don't personally have a lot of time to spend in like Discord or Telegram, but occasionally I pop in there and it's always going. It's like, I don't know how people keep up with it. It's just like the message is, it's like almost like a HFT strategy posting messages or something, because it's so fast, and that's a whole nother skill level to like keep up. But there's a lot of art, it's a lot of humor, a lot of fun. I hope people are having fun. Yeah, it's just really cool.
Yeah, and what would you say you're most excited for on any front? Like, obviously Monad related.
I just want to see some like cool apps. Like that's, we put a lot of work into this, and I think that, when the app teams come in and build apps that really leverage the performance of Monad, I think that's going to be really cool, and that's some validation to what we've done, and I'm really excited to that. And also just learning, because there's a lot of stuff that the app teams have knowledge about that we personally and our core engineering team doesn't have knowledge about. And so like collaborating with them, talking to them, working on the app and helping them, make a better experience for the user, I think ultimately, because that's ultimately what it's all about, is like UX for the user, speed, ability to land your transactions, ability to get cheap fees, ability, reliability, all this sorts of stuff is all about really for the user. And so I think just like seeing what the app teams are building and then working with them, I think is going to be really cool, because it's going to be fun, because I'm going to learn a lot. It's going to be fun. It's going to be really rewarding, because we're going to see them use our technology. And so, yeah, it's just really excited for that next kind of stage of things.
Definitely. Yeah, I think on the application side of things, like, people don't necessarily think that app teams in crypto are forced to make trade-offs based on the environments that they deploy in, but they often are, whether that's, security, how much they can, write into smart contracts and things like that. But when you tap into a network like Monad, which is just so much more performant than everything else that's out there, there's a lot of new use cases that are unlocked and applications that maybe aren't even worthwhile to use in another environment that become worthwhile because of that underlying performance.
Yeah, I mean, I don't have a specific example right now, but we've heard from app teams that wanted to build on various chains, didn't think the performance was there, didn't know how to make the app work on a lower performing chain, this sort of thing. So I'm really excited about enabling like new applications, new use cases, scaling it up. It's both, I've mentioned before, it's not only just like number of TPS is not number of users, it's also can be like the complexity of the transaction, complexity of the application. And so the application per user can be doing more work than you would see in other chains, and then it needs to scale out as well to more users. So it's a combination of both things. It's not just more like, we can support 1,000 users on our order book, and now we can support 10,000. Like that is one thing, but I think it's going to open up more app possibilities of what's possible out there, and people can maybe build some really cool things, and the users will enjoy that.
I will enjoy that as well.
Yeah.
I'm super excited to see some of these live deployments, to get hands on with some of these applications, and I know the community is too, and I know they're grateful for the insight that you're sharing here. So always an honor to have you on the pipeline, James, and appreciate you taking some time away from the bowels of the EVM to come chat.
Yeah, it's great to be here.
Awesome. Cheers, James.
All right, cheers.
Thanks again.
See ya.